So now we're in lesson 3 on page 19, and we're going to talk about non-adjacent angles. So remember, if they're adjacent, they share a side. Okay, so they share a side. Okay, I can even have angles like this. Oops. Angles like this. Okay, these two angles would be adjacent. These two angles are adjacent. Now we're going to talk about non-adjacent angles. So they don't share a side. Now these first couple statements, we're not going to get into it a lot in detail, but what they're saying is if we have any numbers whatsoever, and we know that a plus b equals 180, which statements must be true? Now that's the key. And this gets into some stuff you'll talk about more in geometry and counterexamples. But look at this one right here. Can I say 180 minus b equals a? Yeah, I can. Because a and b have to add up to be 180. So in other words, what they did is they subtracted b from both sides. So they got a is equal to 180 minus b. Now this one says a minus 180 is equal to b. Well, but a and b are positive numbers, probably, equaling 180. So no, that's probably not going to work. This one might work, but we don't know what a and b are, so we're not sure. And this one, even though you're going, oh yeah, that equals to 180, but it must be true? No. Because a could be 20 and b could be 70. So that's the reason this one for sure. The other ones you can't say for sure. Okay? Because this one is definitely not. This one's a maybe. And this one's a maybe. Okay? So we don't know. Because it says must be. So always be careful of that when you're doing it. Okay, this next one you're going to need a protractor for, so hopefully you got a protractor from the substitute, or else they gave you one. And it says we have to identify all angles in these figures that are complementary or supplementary. So right now we're going to pause it and we're going to measure each one of these angles. Ready? Go. Oh, well, I'll do the first one with you. I'll do a couple with you, so then you remember. So here we go. I'm going to line up this on the vertex. Okay. And that's a 90-degree angle, so this is 90 degrees. Then I'm going to use this one, and that's an acute angle, right? So I'm going to line it up, and when I do that, that side matches up here, so it's either 160 or 20. Which one is it going to be? That's right, that one's going to be 20. Okay, and then, oh my gosh, I'm doing them all for you. Okay, you find that other one, find these 4 angles, now you can go. So we found out this angle was 70 degrees, hopefully, when you measure. Now this one, when you go to do it, notice I can't stop here. So I took my straight edge and I extended my line. Okay, now I'm going to measure. And here we go. We're going to line that up. And look, it comes way out here. So is that going to be 55 or is it going to be 125? Well, first off, you notice that it's going this way, but also the main thing you notice is this is up too. So this one's 125. Okay, good. I'm going to let you go again and measure those other 3 angles. So hopefully you found out this one was 65, 125, 65, 125. Good. Okay, so now we've measured them, and it says to identify any pair of angles in these figures that are complementary. What does it mean if they're complementary? That's right, 90 degrees. And supplementary? Exactly 180 degrees. Okay, so in order to be that, they have to add to 90. So CE is 90 degrees. So it can't be complementary, okay, and there's no other 90 degrees to add to be 180, so they are not, okay, and it did say what pairs, so we can only have 2 angles. Pairs means 2. Which 2 angles? Well, 20 plus 70, those add up to be 90, and look at these angles, okay, you can name this angle E, this angle right here is EGF, you can name it that, angle EGF, or angle FGE, E has to be in the middle for that angle, okay? Or, because there's no confusion as to what that angle is, we can just name it by its vertex. So we could also call it angle, like I said, FGE, or we could call it angle G, okay? All of those mean the same thing. So angle G and angle F, or I could have called it EFG, you get the point, are complementary because they add to 90 degrees, okay? Now, what about this? If I take 125, 125 plus 65, do I get 190? Hold on one second. I might have measured those wrong. And I bet, yeah, did you see that I got these wrong? That's actually 55. Okay, so this should be 55, and this should be 55. Thank heaven for erasable pens. Okay, so now, And the reason I knew that is because of my years teaching geometry. And I was like, wait a second, these should actually work out. So if I take 125 plus 55, notice what happens. I get 180. Okay, so angle A and angle B are supplementary. Okay, but also angle A and angle D. Angle A and angle D are supplementary. Okay, and angle B and angle C are supplementary. Okay, and then angle C and angle D. Angle C and angle D are supplementary. None of them are complementary because they're not going to add to be 55. They're not going to be add to be 90. But see how these are supplementary, those are, those are, those are. And you'll learn about those. There's the theorems in geometry when you get to do that in high school. I know, you're excited. Okay, so here we go. Use a straight edge. Well, handy dandy, look at that protractor. It has a straight edge on it. Use a straight edge to draw two intersecting lines. So draw a line, just draw any line whatsoever. And then draw a line that intersects with it. Draw it however you want to. It does not have to be exact. Do not measure it, okay, because we're going to do that in just a bit. So draw one line, and then draw another line. There. I drew two lines. Hopefully yours are different than mine. And since we're not right next to each other, that we won't know. So now what we're going to do is we're going to measure all these angles, and I'm going to number them 1, 2, 3, and 4. So I want you to measure all those angles. These are just markers to say what they are, but you're going to measure the number of degrees. Ready? Go. Okay, I'm going to measure the first two, and then you're going to go. So here we go. I'm going to make this point a little bigger so it's obvious that that's my vertex, where those two lines intersect. Okay, and I'm going to measure those two. Do I need to extend it? Ah, man, just a little bit longer. Oops, and I drew it off. I'm going to extend those lines a little longer. I'm going to extend these lines a little longer so it's easier to use my protractor. So I've extended my lines now, and I'm going to measure again. So I put my spot, my vertex, right on that spot. Line up my lines. Okay, and so I'm measuring this angle right here, and that angle right there goes to, it looks like, we'll say about 1, 2, 3, so that'd be 127. So it's 127 degrees. Okay, then I'm going to measure this angle right here, angle 3. I'm going to measure angle 3, and angle 3 is going to be, get it all measured up. If I do both sides lined up, and it works much better. So this is going to be 50, because it's an acute angle, so it's going to be 50, looks like 53. This is 53 degrees. Okay, see what I'm doing? Now, to measure those other ones, it's easier if you turn your book upside down and measure them. Okay, you ready? Set, go. Now, it's, after we've done that, we measured all of them, and what do you notice? And it says compare your measurements to the people in your group. Well, my group here, there's nobody else here, so I'm going to compare with what I know and what I notice. But do you notice on your paper, I'm sure your angles are not 53 and 127. That'd be a rare chance of it. But do you notice that these two right here are the same measure right here? These right here, these angles right here are the same measure right there. Those are the same measure, aren't those? Okay? And if I were to draw, if I had another highlighter, now you can't see my numbers. This is 53. This is 53. Okay? I would notice that this angle is the same measure as that angle. That's not a coincidence. That is actually going to be true every single time. And what we get to call those angles, do I get to name them yet? Hold on. Let me see if I get to name them or if I have to wait to the end. So these angles actually have a name. And the whole definition for you is just a second. It's going to be here in just in a couple pages. But see how they are kind of like across from each other? See how these colored highlighted ones are across from each other? What I would kind of call across. These are what are called vertical angles. Okay? So they share a vertex, and it's kind of like they face each other. So if I were standing nose to nose with a person, okay, our noses would be touching here, but we'd be looking at each other. That's kind of what vertical angles looking like. We're not going to touch noses right now, though. Okay, or ever, thank you. Teacher and student, nope, I'm not going to do that. So here's 127 and 127. And notice these are the same measure. Those are vertical angles, okay? So we have learned that vertical angles, well, there's a definition. Turn 2 pages. Go to page 22 with me. And it says, when two lines cross, they form two pairs of vertical angles. Vertical angles are across the intersection point from each other. So here we have, this is a vertical angle right here, and this is a vertical angle. So X and X, this angle right here and this angle right here, those are vertical angles. And we have found out that this angle, A and A, are vertical angles. Okay? Now, if you look at that, look at this. Vertical angles always make a V. Look at that. See how those vertical angles? They always make a V. Okay. Good. So, vertical angles. So we've learned that vertical angles are always going to be across the intersection point from each other. But we also learned in our work that vertical angles are always going to be the same measure. Vertical angles, okay, are the same measure. And in the math world, what we would say is we would say that vertical angles are congruent. So angles that are the same measure are congruent. They're the same measure and, of course, the same shape. Okay, so vertical angles are congruent. They have the same measure. Okay, it doesn't hurt to expand our vocabulary. So now we're going to play a fun little game, me and you. So here we go. It says, find the measure of the angles in one column. Your partner will work on the other column. Check in with your partner after you finish each row. We're going to check in after each one. Your answers in each row should be the same. If your answers aren't the same, work together to find the error and correct it. So here's what we're going to do. I'm going to be column A. You are going to do column B. We're going to pause and we're going to find those measures, okay? So here we go. Pausing. You're doing this one. I'm doing this one. Ready? Go. So I looked at this and I saw, hey, wait, this is on a line. That means that it's a straight angle. The straight angle has to equal 180 degrees, right? So I took 180 minus 134 and I got 46. Okay, let's see what my partner did. Well, Mrs. Phipps, what I did is that I noticed this was a 90-degree angle because it has this little symbol. So if it's a 90-degree angle, I'm going to take 90 minus 44. And when I do that, I get 46. So this is 46. Yeah, and you thought I couldn't get any weirder, but no. Now I'm going to even pretend like I'm another person. So you get the idea of what's happening here. Look for this 90-degree angle. Now, it should mark it. See how that marking is there? So that should always be marked. You can't just assume it. But if it has that little square there, you're not assuming, and that means that it is 90 degrees. Okay, so here we go on the next one. I'd like you to do, you're going to do this one, and I'm going to do this one. Okay, here we go. Pausing again. So, first thing I did is I said, hey, it's a right triangle. Okay, whatever. But the angles are complementary, so it's telling me that L and M are complementary. And I know if they're complementary, they're 90 degrees. So I took 90 degrees, subtract off the 51, and I got 39. Okay, let's see what my partner did. Well, Phipps, this is what I did. I noticed that this is a right angle, and I noticed that if that's a right angle and it's on a line, this whole thing has to be 180 degrees. And if this is 180 degrees and this is 90, then this right here has to be 90 degrees. So I took 90 minus 51, and of course I got 39, just like you did, Phipps. Yep, I'll stop being annoying now. But you get the point of what we're supposed to be doing here, is that you find out what these are. Okay, so here we go. We're going to go to the next page. But what we need to see is complementary is 90, and we need to look at everything we're getting. This whole thing was 180, and if this is 90, then this has to be 90 also. This has to be a right angle, because they add up to be 180, because they're on a straight line, a straight angle. Good, let's go to the next page. Okay, I won't do the funny voices anymore. What I'd like to do instead is we're going to pause it, and let's see if you can do both of these. Okay, and I'll come back in, but try it on your own first, please. please make sure that you're actually pausing and doing these. Don't just wait for me to come in and do the work for you. Thank you. So on this first one, I just want to point out a couple things. First of all, it says that they're supplementary. If they're supplementary, that means that they add up to be 180 degrees. So using this, angle C plus angle E equals 180 degrees. Okay? So the measures of those two angles add up to be 180. So I'll let you figure out what E is now if you haven't already. Then this one says it's on a line. So this entire thing is a line. Well, we know a line is also a straight angle. And a straight angle has how many degrees? 180. Okay? So if you haven't already finished that, go do it now. So on this one, I know they're supplementary, so I know they have to add to be 180. So therefore, I can just subtract 129 from 180, and I get that this angle is 51. Then I come over here, and what I did is I said, I know all three of these have to be equal to 180. They're not supplementary, because when we talk about supplementary, it's pairs. It's pairs, two angles. So these three angles do add up to be 180, though. So I took 95 plus 34, 129, and I subtracted from 180, and I got 51. Okay? Let's just look at this last one together. I'm not even going to pause. So what we're using here are many things. We're using many things here. First off, I want you to see how this is a right angle? So that means this has to be 90 degrees. So if this is 90 degrees and this is 42, I can take 90 minus 42, and I can get, on a calculator, and I get 48 degrees. Okay, so that C is 48 because this is a right angle. Now if that one's 48, look at this right here. This angle right here, see how that is a vertical angle to this one right here? Those are vertical angles. So if those are vertical angles, we learn that vertical angles are equal, and they actually look equal. So if that's 48, this is 48. And you'll learn that in math, draw on the picture, write all the information on the picture that you can. So what is this angle right here? So if I take this angle right here, okay, this angle right here, notice it's a vertical angle with this angle right here. So what is B? That's 42. Okay, so now it says two angles are complementary. One angle measures 37. What is this? Find the measure of the other angle. Oh, these are asking questions. We didn't even have to find A and B, but we did anyway. Okay, these are my next two questions down here. I'm sorry, I was a little confused. I thought this had to do with that. Okay, now, B is on a line FW. So that is your big clue there. A line is a straight angle. That's going to be 180 degrees. Find the measure of angle CBW. So we have to find the measure of this angle right here. Yes? Well, these are all on a line. If they are all on a line, they have to equal 180. Okay? These have to add up to be 180. So I can do it two ways. I could write an equation, or I could just go 67 plus 65, come up with that. 132, I believe. Let me double check my work. Yep, 132. And then the whole thing has to be 180 because it's a straight angle. So I'm going to take 180 minus 132. And when I do that, I get 48. So this angle is 48. Okay, good. Let's look at these next two questions. It says two angles are complementary. One angle measures 37. Find the measure of the other. Well, complementary has to add to 90 degrees. One angle measures 37. How am I going to find the other one? Yeah, I'm going to take 90 minus 37. 90 minus 37 is equal to 53. Okay, now it says two angles are supplementary. I'm going to pause. I'm going to let you do this one on your own. Try it. After you've seen this one, try this one. Ready? Go. Okay, so hopefully you tried it on your own, and you know that supplementary angles are 180 degrees, so we're going to take 180 minus 127, and when I take 180 minus 127, I get 53 degrees. Okay, good. Let's look at the summary, because it really does summarize so well, and I want to point out a couple things that I haven't been pointing out as well. Okay, so we already talked about these are vertical angles and these are vertical angles, but here's the other cool thing. Look at this right here. See angle A and angle X, those two angles? Notice they're on a line, and if they're on a line, that means they're on a straight angle. A straight angle has to equal 180 degrees, so these two angles are supplementary. And that's what this shows you here. Vertical angles are always have equal measure. Okay? But we can also see, so if this is 150, and because those are vertical angles, then this angle and this angle are vertical angles. Okay, so this is 30. Now, look at it this way, though. This is 30 plus 180. Sorry, 30 plus 150, which equals 180. So these two angles are supplementary. These two angles are supplementary, and that will always work out. Okay, so look at this right here. If I have this picture, I know that this is also the same as that one, and this one is the same as that one, but I also know that A plus B equals 180. These are on a straight angle. So they add to 180, so they're supplementary. Okay? So then they do a little proof here. They say, well, B are equals and A's are equal, and they add up to 180. Well, then it comes over here, and they're using the same B. Well, they're saying, here's B and C. Those have to be, those are also supplementary. Well, if those are supplementary and B's are the same, then this one, C, has to be equal to A. So it's called the transitive property. We don't get to actually talk about it, but they are. Vertical angles, we have already defined up here. Okay, so vertical angles, the two things that you need to understand about vertical angles is they form two lines that are vertical angles are across intersection points from each other, but also vertical angles are always equal measure. Okay, does that make sense? Let's look at the homework. Two lines intersect, find the value of B and C. We've already practiced that. You can look back over at our notes as to what we're doing there. It says R and S are complementary. Find the measure of angle S. Complementary, what does that mean? 90 degrees, exactly. Now it says if two angles are both vertical and supplementary. Well, what do we know about supplementary? That has to add to 180. Add to 180. Vertical means that they have to have the same measure. Okay, we found out that they're going to have the same measure. You can't read that. So, vertical angles have to have the same measure. So vertical angles have to be the same. Supplementary have to add to 180 degrees. Okay? Use that information because it says, can we determine the angles? What could the angles be? What could be the measure? Can we find out what those angle measures are? Then it says, what if they are both vertical and complementary? Look up what complementary is if you've forgotten and tell me what you know about those. Tell me what those angle measures would be. Good. Number 4, match each expression in the first list with an equivalent expression from the second list. So what they want us to do is they want us to simplify all these things. So I'm going to do a couple with you. I will take the yucky ones, okay? You can take B, that one's nice. A, you have to distribute, so just make sure. So we're going to do that one. We're going to distribute this. 5 times x is 5x, and 5 times 1 is 5, minus 2x plus 11. Now I'm going to combine like terms. Oops, nope, I'm going to cross the line and change the sign. Combining like terms, I get 3x, and then 5 and 11 are also like terms, so that's going to be 16. So A matches up with 4. So I'm going to just put an A right there. Those match up. You're going to do B. I'm going to do C. First thing I'm going to do is I'm going to cross the line and change the sign. Then I'm going to combine like terms. They both have an x on it, so they're like terms. Negative 3 plus a positive 5 is 2/8x. Negative 9 and positive 1 are also like terms, and that gives me 8. Do we have an answer yet? Well, it doesn't look like we do, because they have 1/4 and we have 2/8. Yeah, you already picked it out, didn't you? 2/8 in lowest terms is 1/4. Ah, and I dropped a negative on my 8 because I had a negative 9. You already got that, didn't you? So this is C. If you draw the lines, it's really confusing. Just write the letter over here. Now here, use a calculator for these, okay? And then this one, they want you to factor. Look at this, 99x plus 44. What can these both be divided by? They can both be divided by an 11. So if I divide both of these by an 11, I get, in parentheses, because I'm factoring out the 11, I get 9x plus 4. Where does that match up with? That's E. Ah, I think you can figure out, even without doing too much work, which one are 2 and 5. Good. Let's go to the next page. factor each expression, we were just doing this. So I'm going to do C because that's going to look the worst to you, but you want to find out what they have the same. Now, on A, I'll give you a hint. It's a letter. You know what? Let's just do them together. So what does A have in common? 15A and 13A. They both have an A. So I'm going to factor out an A. I'm going to divide them both by an A. When I divide, I know some of you are going, oh my gosh, we cannot divide by a letter. Oh yeah, we can. Okay, so my A's divide out to 1, so I get 15. My A's divide out to 1, so I get 13. Okay? That's what I do as far as if I was factoring. But look at this problem again. 15A minus 13A. See how they're both like terms? So I would just go 2A. Why we're factoring? I don't know. I think it's kind of silly, personally. B, what do they have both in common? What can they both be divided by? Right, they can both be divided by a 6. But see how they both have a negative? You can actually divide both of them by a negative 6. When I divide both of them by a negative 6, my 6 cancels. I have an X. Now I'm taking a negative, because I should have crossed my line and changed my sign right there. And when I take negative 18 divided by a negative 6, I get a positive 3. And I still have a Y. Good. Look at C. Okay, 36 and 54, what can they both be divided by? 9. Nice job. Now then, A, B, C, and AD, do they have a letter the same? I sure do, that A. I'm going to take that out. So I'm going to divide both of these by 9A. So my 9 goes into 36 4 times. My A's cancel to 1, so I have a 4BC. 54 divided by 9. That's right, it's 6. This is a B. Now my A's divide to 1, so I have a D left. Nice job. Okay, let's look at 6. The directors of a dance show expect many students to participate, but don't yet know how many students will come. The directors need 7 students to work on the technical crew. 7 on technical crew, and the rest will work in groups of 9. Okay, to show their work, they need at least 6 full groups working on dance routines. So this one was really confusing, and I read it again. And so here's the thing. We have 7 students. We need groups of 9. Do we know how many groups? Nope. Okay, they need at least 6 full groups working on dance routines. Okay. So the rest of the students work on dance routines in groups of 9. So we're going to have to pause and look at this one again because I'm confused. I don't know about you. So this one has me so confused. I'm not sure exactly what we're supposed to do. If I were in an algebra class, I would say that would be my inequality. But here's the good news for you. I'm not going to worry about it because it is so dang confusing because it's when I solve this equation, it's like 400, oh, I can tell you. It's 479 students. So you know what? We read through it. We're going to count that as our reading lesson today. Number 7, just as confusing. I'm okay. Not doing that one. So 6 and 7, you're done. Good. I did 5 for you. I did most of 4. So in other words, your homework assignment is pretty much 1, 2, and 3 and finish 4. Yay you! Okay. Do those, please. And if you finish your work, make sure that you go back and look at your missing assignments and get those into me. You can take pictures of your missing work and email them, or get onto a Google Meet with me and show me your work. Thank you very much. Bye.